Let's now look at machine learning pipelines. Since this module is about scalable machine learning, so we will mainly study the machine learning library of Spark or MLlib. So in this library, it provides machine learning algorithms, which are common machine learning algorithms for regression, classification, clustering, and collaborative filtering. This library also provides methods for featureization. These are those methods for feature extraction, transformation, dimensionality reduction, such as PCA, and feature selection. And it also provides pipelines, which are the tools for constructing, evaluating, and tuning machine learning pipelines. And it also has the persistence functionality for us to save, load the algorithms and models and pipelines. It also provides utilities, including linear algebra operations, statistics, and data handling functions, and many others. So there are several important concepts in the machine learning pipelines. The first one is data frame. So data frame, as we have just learned, is basically a machine learning data set. Right? Data frame is basically a special kind of data set. It holds various data types. For example, the columns for text, for feature vectors, for true labels, and for predictions. Right? So we will see many examples in the lab. And another concept is transformer. Right? So we have learned transformer is essential in Spark, right? In Spark. And the transformers in machine learning library are those algorithms that can transform one data frame into another. Right? So, for example, a machine learning model can transform features to predictions, right? To generate a predicted output. So this machine learning model will be a transformer. Another concept is estimator. So estimators are those algorithms that can fit on a data frame to produce a transformer, right? So the output of an estimator is a transformer. For example, we have a machine learning algorithm which can fit on training data to generate an estimated machine learning model, right? So in this case, this machine learning algorithm will be the estimator. Another concept is pipeline, right? So pipeline basically, it chains multiple transformers and estimators together to specify a machine learning workflow. And lastly, the last concept is parameter, right? So here, all the transformers and estimators, now they share a common API for specifying the parameters. So machine learning pipelines are high-level APIs, right? They are much higher level, and they are for create and tuning machine learning pipelines, right? So here is an example. So this is a pipeline model. And we start with data set 0, DS0. And the first transformer we have is tokenizer, right? So there is tokenizer. The input is text, and the output are words, right? So output are words. So the next, that is a data set one, right? Data frame one, right? So the next transformer is hashing TF, right? TF means term frequency. The input are the words and the output are the features, right? So basically, this is a feature extractor, right? Extract feature from the words, right? So, and that will result in the features, which is the data set 2 over here. And in training, this training data set can be passed to a logistic regression to learn a model, right? To estimate the parameters for the logistic regression model, right? So that will be the output, which is the model, right? So then this will be an estimator. And then in the testing phase, right? In the testing phase, the features will be passed through this model, and this model will generate a prediction, right? So which is the DS3, right? Data set 3 here. So that is the prediction, right? So then when we have defined this tokenizer hashing TF and LR, we define a pipeline over here that basically chains the three transformers, right, together. And once we define this pipeline, we can use it, right? We can use it, for example, if we create a data frame from a external data, and we can just fit, right? Just fit the pipeline to this training, to this data set to obtain an estimated model. Now let's look at an example of a text classification, right? So using the pipeline just now. Here we are given a text document and we want to predict its topic, right? So here's a given text is this is from the UCI KDD archive, the 20 news group data. And we have a binary label, right? So it is 0 if it's not about science, and it will be 1 about if it is about science, right? So it's just a simple binary classification problem. So the machine learning workflow will be quite standard, right? So basically the first step, we need to load the data, and then we need to extract features from the data. And then these features will be used to train a model. Then after we train the model, we need to evaluate our model. So let us look at the first step in the workflow, which is load data. And so when we do the load data, we can load data from various data sources, right? Either have built-in functions from Spark, or you can use also external functions, right? External functions to load the data sources. And in this step, right? So the data schema look like this, right? There will be a label because our data are labeled data, right? So it also have the text, right? So that is, so you can see the type, right? So you can see the type for label is an integer that is just 0 and 1, right? So just 0 and 1. And the type for text, right? So text is schema is string, right? So those are the actual text, right? So these are the current data schema, right? The current data schema. And now let's move on to extract features, right? Extract features. Here, the extract features actually has 2 steps, right? Has 2 steps, right? So we will have one. The first step is a tokenizer, right? So basically to generate words from the text, right? Generate words from the text. And a second step is hashed term frequency, right? So these will generate feature vectors, right? These will generate feature vectors, right? So both of these two are transformers, right? So they are transformers. Tokenizer will generate basically this will add to the schema. It will add one more column called words, and its type is a sequence of strings, right? So it's a sequence of strings. And for the hashed term frequency, it will generate a column called features, and its type is vector. Its type is vector. And then we move on to the logistic regression estimator. In this estimator, it will basically generate, it will output the model parameters, right? So model parameters. It will generate the model parameters, but here we are not going to put it in the data schema, right? So because this is more model parameters, right? We have a particular APIs for the parameters, right? So model parameters. And then when we have that model, right? When we have the model parameters, then this logistic regression can be used as transformer, right? So in the previous slide, this is an estimator, right? Because we are actually we are estimating the model parameters, right? So it is an estimator. But once we have that model, right? So then this logistic regression will become a transformer, right? It will become a transformer for the testing, right? So what it will generate will be a prediction, right? So it will generate another column, right? Another column in the data frame, and the type is integer, right? The type is integer. So this will be passed to the evaluator, right? So the prediction will be further passed to the evaluator to evaluate the performance, right? So therefore, in this operation, by default, Spark will always append new columns. Right? We will always append new columns. You can see that in the lab, right? So the benefits are by appending new columns, we can go back and inspect the intermediate results, right? So to make sure that we are doing the right thing and also to spot errors. And also this can be made efficient by the data frame optimizations, right? They can be made more efficient by data frame optimizations, such as using catalyst, right? So catalyst, right? So that is the machine learning pipeline, right? So and how the schemas just add new columns, right? When we move across the pipeline, right? So it is very standard, right? So it is very standardized workflows, right? So for example, we can use the same pipeline, right? So you define the same pipeline over here. We can define the same pipeline here consists of tokenizer, hashed term frequency, and logistic regression. Right? So we can use we use this same pipeline for training, right? For training to estimate the model, and also for testing, right? So that is the same pipeline, right? The same pipeline can be used for both training and testing, right? So we just rerun the same way, right? Rerun the pipeline the same way. And machine learning library can also facilitate parameter tuning, right? So parameter tuning. It has a method called cross validator, right? So called cross validator. And it will take estimator, parameter grid, and evaluator as an input to find the best parameters for you, right? So it's highly automated process, right? So for example, you can specify 3 parameters. These are more like hyperparameters, right? They are hyperparameters. So here, right? So here the parameter refers to hyperparameter, right? So it's not very precise, but you should know that this parameter talking about the hyperparameter, right? So this is talking about hyperparameters such as the regularization parameter and the hashing parameter, right? So that's all for the machine learning pipeline, right? So in the last section, we will talk about the parallelization of that Spark execution.